We'll study polynomial interpolation sequentially, starting with linear or affine polynomials, then quadratic polynomials, then cubic, and finally make the discussion general for a degree n polynomial. Let's start with linear. A linear or affine polynomial just has two parameters, right? It's of the form a0 plus a1x, where a0 and a1 are the parameters of the polynomial. The polynomial is a function of x. Given any two data points, x1, y1, and x2, y2, with the x's different, then there exists a unique choice of parameters. These are really the slope and the y-intercept, so that the polynomial evaluated at each individual x gives the corresponding y. There's a picture of an x1, y1 pair and an x2, y2 pair, and clearly there's only one straight line that passes through those 2 points. You could determine that straight line, figure out its slope and its intercept, and that would be the formula for the linear affine polynomial that interpolates those 2 points. Clearly it's an easy system of equations to solve. It can be done any number of ways. Let's write out this constraint as a system of linear equations involving the coefficients a's. The first equation says that a0 plus a1 times x1 should equal y1. The second equation says that a0 plus a1 times x2 should equal y2. So there it's written in the form of ax equals b, where the a array comes from the x data. The x unknown is the coefficients a0 and a1. Those are to be determined. And the known b vector is from the y data. This is a square system of equations. As long as x1 is not equal to x2, there's a unique solution, and you can use the backslash operator to solve that. Let's follow the same idea and move on to quadratic polynomials. A quadratic polynomial has 3 parameters: the constant term a0, the linear term a1x, and the quadratic term a2x squared. Now, if we're given 3 data points, x1, y1, x2, y2, and x3, y3, with all of the xi distinct from one another, then, again, there exists a unique choice of parameters, a0, a1, a2, so that the quadratic polynomial evaluates to the corresponding value of y at each x. Here's a picture of that. 3 data points, x1, y1, x2, y2, and x3, y3, and I've drawn the one quadratic polynomial that fits through those points. Let's write this equation at the 3 locations down in matrix vector form. We see a0 plus a1 times x1 plus a2 times x1 squared equals y1, and then a similar set of equations for x2 giving y2, and a similar set of equations for x3 giving y3. Again, this is simply in the form of ax equals b. A is a 3 by 3 array made up of the x data. B is a 3 by 1 vector made up of the y data. And x is the unknown coefficients of the polynomial. Again, this is a square system, and as long as the xi's, x1, x2, x3, are distinct from one another, this has a unique solution. So again, backslash can be used to solve this. Try some quizzes out and see if you're able to implement these ideas. Use MATLAB to solve these systems of equations and produce the numbers that the quizzes are asking for.